Mindu and Professor Ravi Kumar. And then these are all the participants. Okay. And these are mechanical professor or electronics professor?
We are actually the department which is conducting this STTP is mechanical, sir.
Okay, so
And
all of them are mechanical, or there are some people who are electrical and electronics also?
In the participants, electrical and electrical faculty are also there, sir. In the
some automobile also, some faculty automobile also.
Fine. So can we ask them to raise the hand who are pure mechanical?
Yes, sir.
Please raise your hand. Yeah. Yeah, there are many with pure mechanical.
Yes.
And how many are electronics and electrical? Please put your hands down. And how many are electronics and electrical? Those mechanical can put their hands down, and electrical electronics can put their hands up. Okay, there also we have a good chunk of number. Okay, so we have a mix of both. Fine. So today I'm going to talk on introduction to electric and hybrid vehicle, and I have around 90 slides. And how much time I have till what time?
The total time is 1.5 hours, sir, including the query session.
Fine. So 2:45 to 3:45.
Yes, sir.
And 4:15. I have to finish by 4:15, right?
Okay. Yes, sir.
Okay, fine. So I will go slightly faster. Initially, I'll be slow, and then slowly I'll pick up the speed.
Yes.
Okay. So I would just take you in the history of electric vehicle. Somewhere in 1832, the research on electric vehicle started. And then we had the first electric taxi from Paris to New York and back in 1889. And then electric vehicle became very famous. Just 1 second. Give me 1 minute. Yeah. Hello. हाँ, वेरी गुड. और राजेश पाटिल ने आपको कुछ काम दिया? हाँ, तो मुझे मेरा काम है वो अभी बोलेंगे आपको. From 1st April 2019 to 31st March 2020, वो पूरे साल का आउटस्टैंडिंग 1st April 2020 को कितना था और 1st July 2020 को कितना था, और वो अमाउंट और इन टर्म्स ऑफ परसेंटेज ऑल्सो. हाँ, करेक्ट. और 1st जुलाई या 31st जून कल तक का. हाँ. ओके. हाँ, पिछले साल का 1920 का. हाँ, तो मुझे और राजेश को ईमेल कर दो. Okay, so let me switch off my phone. Okay, now there won't be any disturbance, and let me put my mobile in silent mode. Yes. So then in 1907, Detroit Electric started manufacturing electric vehicle, and then for Porsche also started building electric vehicle. Then by that time, Henry Ford came with its mass-produced T car. And this car became so popular that people reduced purchasing electric vehicle, and they all moved towards Henry Ford's cars. Ford motor cars became very popular, and electric vehicles started disappearing from the market. Then came the oil crisis. The prices of the crude petroleum went up like anything, and this compelled people to rethink on various options. Moreover, California Air Resource Board came out with Clean Air Act and zero emission mandate. So Clean Air Act came in 1970, where catalytic converters were compulsory, and zero emission mandate came in 1990, where all the vehicle manufacturers to produce at least some vehicle which will produce zero emission. That means they were forced to produce electric vehicle. this brought a lot of interest in the electric vehicle, and people started working on it. India worked on electric vehicle, Europe worked, Japan also worked on electric vehicle. Not much work was done in USA. So in 1991, a model called CAVET, and later on this model was renamed as Buddy in Europe. Then in 1997 and 1999, Toyota and Honda, the Japanese company, started working on electric and hybrid vehicle and launched the products. Meanwhile, in India, Mr. Chetan Maini from Reva Electric, he produced the electric car in Bangalore, and he was able to sell few of them. Later on, Mahindra took over Reva Electric, and now it is called, then it was called Mahindra Reva Electric or Mahindra Reva, and then now it is called Mahindra Electric. Tesla was formed in 2004, and 2008 they came with their first model. And then we have Nissan, who came with another vehicle called Leaf. So like that, we have a very good, strong presence of Japanese and European in the electric vehicle market. And with Tesla, American also got the share of the pie. Now, why are we going for electric vehicle? There are many reasons. So what are the problems related to mobility for the 21st century? So mobility has become a very important part of our life, and mobility has become a necessity more than the luxury these days. So you will find in cities, every house has a car, a two-wheeler, and sometimes two cars and two two-wheeler. And father also has a car, mother also has a car, children going to college also has a car. This is all because of economics, because of good economy and affordability. People have been able to do so. Moreover, it has also become a part of the necessity. Now, more and more people from the villages are shifting to cities. Today, 50% of Indian population, around 40% of Indian population is staying in cities, and it is predicted by 2030 it would be 50%. So when the population, human population increases in city, obviously the vehicle population also increases because of affordability, and then you will find problems like traffic, strong traffic, congestion, emission, accidents, unsafe, and then the infrastructure is not increasing, the roads are not increasing, multiplying as the number of vehicles are multiplying. So we may be having around 250 million vehicles running on Indian roads. So because of this increasing traffic, urbanization, increasing population, we get a lot of issues like pollution, noise pollution, air pollution, unsafe problems, and all those things. So we need to take care of our environment. We need to ensure that COHC, NOx, and particulate matter are minimum, for which government has come out with various standards. There are norms for CO2 emission also, which are not notified, but it is self-imposed norm by the vehicle manufacturer. So all these things are leading to use of electric vehicle. Moreover, petrol and diesel prices are like 80 rupees per liter, and it helps us to think that we must start working on electric vehicle. Yes, we will see that whether electric vehicle is more polluted or whether IC engine vehicle is more polluted. You will see here, just 1 minute. You will see that in 1979 there was a peak. Generally, crude petroleum is sold at $25 per barrel, but in 1979 there was a peak of 125 this thing, and in 2008 there was a peak of $145. So these peaks are frequently coming, and whenever such peaks come, people start thinking of an alternative, and electric vehicle is one such alternative. So as I told you, the urban cities are increasing, and by 2050, this would be more than 50%. Today, Bangalore, Mumbai, Pune, and Delhi have the highest congestion level of vehicle. And we also talked about the standard. So this on the right side is the BS6 emission norm, and left side is how much CO2 emission are being produced. So compared to China, US, and Europe, India produces very less CO2, but the growth rate, the rate at which these CO2 emissions are produced are very high in India. We talked about global warming, we talked about CO2 emission, And they say that if this if CO2 emissions are high, there will be global warming. The temperatures will increase, and if the temperature increases by 1 degree at the equator, at the North Pole and South Pole, it will increase by 12 degree, which will melt the glaciers. And there are certain cities like Bombay, Kolkata, they will get submerged in water if this continues. The temperature may go above 50 degrees Celsius in all the major cities within a couple of years. So there is a need to have electric vehicle which will reduce the overall pollution in the cities, and which are called zero emission vehicles. You would see that India produced 3.6 million passenger vehicles in last year and 21 million two-wheelers. So last year we surpassed China and we produced 21 million two-wheelers and around 1 million commercial vehicles and three-wheelers. So electric vehicles are here to stay, and we will have to seriously work on this option to reduce the pollution in the cities. In electric vehicle, there are different types of vehicle like battery electric vehicle, hybrid electric vehicle, plug-in hybrid vehicle, and fuel cell vehicle. Right now, we are talking about battery electric vehicle, which is the cheapest of all four. But in future, we may have to go for hybrid. That means the engine also would be there and the motor and battery also would be there. But this is going to be a costly affair, but it would be more efficient. Sometimes we have a vehicle where you don't have to charge at all. The engine will charge the battery. But otherwise, we have a plug-in hybrid where we need to plug in the car in the night to charge. In future, we will also use fuel cell electric. So in a typical electric vehicle, we have a battery which gives DC current, and then DC is converted into AC by an inverter, which goes to the electric motor, and then from there it goes to the gearbox or the transmission, and then to the wheel. And there is a controller which takes care of all these controls. So the electric vehicles could be of different type, but what is important is the electric vehicle must positively have a battery pack, a motor, an inverter, and a battery management system known as BMS. So once again, an electric vehicle has four major components. So there are four pillars of the component. First one is called electric machine, that is electric motor. Second one is called energy management system or battery management system. Third is called power electronics or power control. And fourth is the energy storage devices like batteries. So these are the four major components of an electric vehicle, and the entire electric vehicle depends on these four strategies. So when we look at the degree of hybridization, more and more people are converting, using electric vehicle, hybrid vehicle. Yes, it is not 100%. Last year, we sold only 3,600 electric cars, but more than 6 lakhs three-wheelers and more than 1 lakh two-wheelers. So to start with, it has to be a micro hybrid. That means you must be able to start, stop and go. So it is an engine start-stop mechanism, and slowly we will use brake energy regeneration, integrated motor assays, and then pure electric drive, and then power charge from the grid. That is what is the growth path. So in short, we have traction motor, auxiliary motors. So these are various components of an electric vehicle, and the motors have become a very important part of the electric vehicle. So here you can see there is a motor, it gets loaded, there is a power modulator, there is a battery, and there is a controller. So this is how an electric motor looks like. Basically, it uses magnet between the stator and rotor, and these magnets are coming from China. So now that we have stopped getting parts from China, we are slightly worried that how will all these magnets come. So Pune has taken the lead in manufacturing these magnets and then supplying for the electric motors. So this is how there is a stator, there is a rotor. Okay, so these motors can be of different type: permanent magnet motor, PM, induction motor, IM, or SRM, switch reluctance motor. So depending on type and requirement, the motors can be used. For example, these top three types of motors could be used for induction, or for permanent magnet or synchronous reluctance. So you would see that most of the passenger vehicles uses induction motor or permanent motor. So if you see the properties of this electric motor, they are highly efficient motors. Their efficiency is always greater than 80% and ranges between 80% and 95%. The torque characteristics and the power characteristics of the electric motor are also good. So when you look at the selection criteria of electric motor, you can decide based on the payload of the vehicle, acceleration, braking, the performance required from the vehicle, based on the motor system, based on the motor itself, and then based on the controller. So these are some of the areas which we need to study and accordingly decide what we want to do with the education system. So let's quickly look at the technical part, that when I take a motor, electric motor, then what is important is it has to be low cost, high performance, and high durability application. So if we draw a matrix, you will come to know that these are the three areas on which one has to work and then converge in such a way that we take the advantage of all of these things. So a lot of people have worked on electric motor design, and most of them have worked on the software. So you will see that in this electric motor design, electric machine, design specs, electromagnetic design, reduce order model, all these are used. And then we have magnetic design and optimization, we have optimized thermal management. Yes, so motor design requires analytical design, finite element methods, thermal and structural integrity, and then system analysis. So there are various configuration. Mahesh, just Mahesh. Akshay, message here. Yes, we continue. So there are different types of motors. So motor where the motor is in the central drive below the floor of the car, or the motor which are there in the wheel hub itself. So a lot of research has been done on this, and there are in India also there are many who have come out with motor in the wheel hub. The second important aspect of electric vehicle is the power electronics. So we need power supply, utility network, magnets, circuits, feedback control, system operation, which are very, very important from power electronics point of view. And also it is necessary that we must check the cost, size, and weight of all these parts. So in power electronics, we may have to use a DC-DC converter or an EC-DC rectifier, but all these components are very, very important. So in power electronics, we can use various software to finalize the design of power electronic components. The third component is EMS, Energy Management System, which is popularly known as BMS, Battery Management System in electric vehicle. So battery management system the major work of battery management system is to maintain the temperature. So it will check the temperature. There may be 4 or 5 thermocouples connected to the battery. And whenever the temperature shoots up, it will give a command and the cooling will further get enhanced. So the state of charge and the state of health, the temperature, the cell balancing, all this becomes very, very important parameter. And we need to all work on that. Battery management system will combine all these things into one system and take help. The last important aspects of electric vehicle is the battery itself, the battery or the storage system. So we need to design a battery. Generally, batteries are made out of packs, battery packs, like the picture which you see here in white and red. And then each pack is made up of various modules, and each module is made up of various cells. So we need to also decide the C rate of the battery. For example, if I say it is 1C, then it charges in 1 hour. If I say 2C, then it charges in half an hour. If I say 3C, then it charges in 20 minutes, and so on. We also need to do battery thermal analysis and the subsequent cooling. For example, the battery cooling can be by air convection or liquid cooling through channels. So we need to take those decisions and move forward accordingly. Yes, so let's wait for a while and see Dr. John B. Goodenough, who is a professor and a physicist who has done extensive research on the battery. So Dr. Goodenough has worked on lithium-ion battery, and he is said to be the father of lithium-ion battery. But he is now working on glass batteries, and if things succeed well, then glass batteries would replace the lithium-ion battery. So these are some of the battery pictures you see here. So on my left is the lead acid battery, on the right will be the advanced battery, which could be lithium ion or it could be nickel metal hydrides. Okay. So the batteries could be of various shape and size: cylindrical shell, pouch cells, prismatic shell. So we already saw that there is a battery cell, and a group of battery cell constitutes a battery module, and a group of battery module constitutes the battery pack, and a group of battery pack constitutes the final product. So here you can see different types of batteries. And then how batteries are designed, you need to consider its electrical, thermal, structure, and chemistry aspects. So these batteries are required for various applications. It could be truck, it could be just two-wheeler, it could be car. And we need to decide whether we require high energy from the battery or high power from the battery. And based on that, you can decide whether the performance curve of the battery lies in the high energy range or the high power range, and accordingly take a decision. So there are various material which can work as a battery material based on its electrochemistry. So nickel cadmium, nickel metal hydride, lithium ion, lithium metal. These are some of the batteries, type of battery material which are useful. Then there are various countries which have mines for lithium. So Argentina, Bolivia, and Chile has maximum reserve together for the lithium. And against that, there are many companies who import lithium, but it's a difficult game. The next question is, the batteries are there, the cars are there, the infrastructure is there, but where is the charging station? Yes, so I am sure that you all must have expected that there will be a lot of charging station, and when you buy an electric vehicle, you don't have to worry, you can go anywhere and charge. Yeah, that's what Ether Energy is planning. Anyone can go anywhere, and if the battery is there, they can get it charged. So the next is EV charging. So the charger may be safe, scalable, saving security and simplicity. So even though this looks very simple, but it is very, very complicated, and we need to have exercise right control before it takes the U-turn. So government is working on various initiatives for EV charging, and government has suggested that multiple initiatives by government to promote adoption of electric vehicle with FAME 2. In December 2018, Ministry of Power has released guidelines for charging. And this is a table which shows that fast charging, slow charging, what is happening. So this is a typical charging system developed by AREI, and if somebody wants to buy it, they can buy it. So here is what I talked about in the beginning: well to tank and tank to wheel. Indirectly, we are trying to find out well to wheel. What is the contribution in terms of emission? Any questions up till now? Hello, am I audible?
Yes, sir. Yes, sir. You are audible, sir.
Okay, just give me 2 minutes.
Yes, sir. No problem. So till now, any questions are there? Participant, please post in the chat box here to the owner, sir.
Two hand raises are there. We'll ask the questions once Horace again come back. So meanwhile, I request all the participants to rename themselves according to the name that you have registered in the Google form. So many participants have entered into the meeting with their device name. So if that is the case, we couldn't able to get your attendance. So I request you to kindly rename yourselves.
Okay, I am back. Yeah. So we have finished 25% of our presentation, and let us compare electric vehicle with an IC engine vehicle. So when we talk about well to wheel, we can divide this in two parts, well to tank and then tank to wheel. So when we talk about well to tank of an electric vehicle, wherever electricity is produced, whether it is thermal power plant or a solar power plant or a wind power plant, from there the electricity is produced and it passes on through the transmission system to our home, where we can charge our batteries, or it passes on to the charging station where we can charge our batteries. So the transmission of electricity from the source till the electric point is very poor, around 30% efficiency, whereas the use of electric vehicle from the tank to the wheel is highly efficient. We already saw that electric motors have efficiency more than 80%. Or similarly, for an IC engine vehicle, you would see that when the coal is fired in a thermal power plant, electricity is generated. Sorry. When the fuel is refined, when the crude petroleum is refined in a refinery, then petrol, diesel, and other fuel are generated, and that efficiency is very high till it reaches the petrol pump. Once the fuel gets filled up in the car, then its efficiency goes down. So a typical thermal efficiency of an engine is 30 to 40%. But when you include till the wheel, that is from the tank to the wheel, the efficiency may be quite low, as low as 20%. So you would see that which is more beneficial, but and accordingly you can take a decision. But let's take an example with respect to the emission. Say if you take a normal gasoline vehicle with catalytic converter and all those things meeting BS6 norm, then it may show a very high CO2 emission and a moderate NOx emission. But when you use electric vehicle charge on grid, then the CO2 emission will drastically reduce, the NOx emission will also drastically reduce. However, if we use renewables like solar energy, wind energy, hydropower plant, or nuclear energy, then there will be zero CO2, zero NOx, zero PM, and we say that this is a zero emission vehicle, a true zero emission vehicle in real sense. So let us see how is the sale of automobile electric vehicle worldwide. So there are countries like Finland, South Korea, Australia, and Netherlands who sells lot of electric vehicle. But the most important country is Norway, where they sell, the penetration of electric vehicle is more than 50%. They sell a lot of electric vehicles in those countries. So who manufactures maximum electric vehicle? So it is China, USA, and Norway. These are the three countries, China, USA, and Norway, who manufactures a lot of electric vehicles. But in Norway, being a small city and a small population, the number of vehicles which have been encouraged to buy electric vehicle could be as high as 56%. So more than 50% of the people tend to buy electric vehicles. Then there are other countries like Ireland, Sweden, Netherlands, Finland, who has very good percentage, around 5% share of electric vehicle. So if you say in terms of passenger car, if 3,600 electric cars were sold last year, among 3.6 million cars sold in 2018-19, that comes to only 0.1%. So where is 56% of Norway or 2% of US? We are talking about 0.01%. So that is the reason because of which we have to target a better sale of electric vehicle in India. So India has a potential to sell electric vehicle in large number to curb the menace of degrading, but we don't know what will be this penetration. That means by 2030, whether today we have sold only 0.1% of electric vehicle, but by 2030 there will be many takers for electric vehicle. How will sale of electric vehicle in India would be? Whether it will be 5%, 10%, 20%, or 30%. We need to decide. So if you look at the green color table below on the left, you will say last year we manufactured 1,26,000 vehicles, that is two-wheeler, and we sold 6,30,000 three-wheeler, and we sold around 3,600 electric vehicle sale. So there are various predictions. They say that by 2030, the penetration of electric vehicle may be 8%. That is what Goldman Sachs says in this graph. Or SIAM says there will be 40%, Society of Indian Automotive Manufacturer. Or Niti Aayog says it would be 30%. So there are various opinions, and they are all varying between 70% and 90%. So how would India support the move in the electric vehicle? They have developed a National Electric Mobility Mission Plan. They have also introduced FAME scheme. FAME is faster adoption and manufacturing of hybrid and electric vehicle in India through Niti Aayog, the think tank to the government of India. And there also they have incentivized EV ownership by subsidizing upfront cost of purchase combined with GST rates. We talked about charging infrastructure. So EESL, Energy Efficiency Service Limited, has floated tenders for supply of 10,000 batteries and other parts. Okay. We have also made standard for the electric vehicle charger. Okay, just 1 minute. We are halfway through.
Yes, sir.
Yeah, we are on time. You will be able to finish it by 4. So Niti Aayog has come out with a paper called India Leaps Ahead, Transformation Mobility Solution for All, where they have talked a lot of things about electric vehicle. So they have said that India can save 64% of the anticipated road-based mobility related energy demand and 37% of carbon emission by 20% by 2030 by pursuing a shared electric and connected mobility results. So the prediction says that it is not only engine which will survive. If you really want the vehicle to survive, you need to take care of the vehicle and then work on it. Okay. So government of India has understood this, and they have to make a policy decision for cost reduction in battery manufacturing, or for uh, revamping of energy sector to meet the demand of electric energy by 6 million electric vehicle, or developing a charging infrastructure ecosystem. So a lot of work is required based on this policy matter. So lithium ion is one of the most important component of a battery, and one is to search for that. So today what is happening is India to have 40 GVH of installed lithium ion battery, making it one of the fastest growing industry in the next decade. So you would see that the production capability will eventually increase, but what looks like is that Gujarat and a bit of Maharashtra and Telangana are the area where one has to be serious. So we talked about FAME, faster adoption of electric hybrid vehicle. So earlier we had FAME 1, where it was discussed that we give around 15% subsidy, but now it is not based on the percentage. It is based on the performance besides the subsidy. So how do you follow up for the grant is also very important. So under FAME 2, under FAME 1, it was based on the cost of the vehicle. Now it is based on the motor size and how fast you reach. So there are many startups, as I told you earlier, who are working on electric vehicle. Say, for example, in a two-wheeler industry, Ether Energy, Ether Energy, Torque Motors, Revolt Intellicorp, Influx Motors, and Ultraviolet Automotive. These are some of the startups who have been producing electric two-wheelers in India. So, and suddenly you will find a big boom of a lot of electric two-wheelers running on the Indian roads. So these are some of the models being launched. These are all smart vehicles. Okay, so these are some of the companies who are startups here. So there are various predictions. As I said, SIAM predicts 40% penetration, Niti Aayog predicts 30% prediction, and Golden Sach predicts 20% prediction, and so on. So we have a challenge that we have to absorb the upfront cost of EVs. EV adoption is closely linked with complementary charging infrastructure and distribution of structure distribution structure very significantly. And we can also work on the swapping of the batteries. So if you look at worldwide, purchasing a standard medium-sized EV is approximately 40% more expensive than a conventional IC engine of the similar size. And the cost of ownership varies from 3 to 5 years. Scaling up the customer adoption of battery electric vehicle in car will require policy statement. Battery on lease to make two-wheeler cost effective. So there is a company called Ether Energy who sells intelligent two-wheeler with electric vehicle capacity at say 1.5 lakhs rupees. And they say that, okay, if we are able to if you don't sell the battery and we lease you the battery, we give you the battery on rent, then the cost will drastically reduce by 1,500 per year. Okay. So what are the challenges worldwide? First challenge is range anxiety. Whether my car, I have to stop after 1 hour, 2 hour, 3 hour, or after 100 kilometer, 200 kilometer. So this range anxiety is there, and everyone wants a higher range. I must be able to charge it for 6 feet distance and all those things. You would see that the range anxiety among Indian drivers are very high, and not about the owners. And We are not sure what type of range we want, but it could be as high as 400 kilometers. So for 400 kilometers, what type of system we need is what is important to study, or we need to use range extenders to increase the requirements. Then comes the charging infrastructure. Charging can be done directly by the battery through the mains, or we can use a solar panel, or we can use wind energy. These are some of the areas where we can have a challenge. So in terms of charging time, we have to see when the battery gets discharged and when it gets fully charged, how much time it takes. The state of the charge and state of the health, SOC, SOH, are very important for a passenger car. Okay. So let's classify electric vehicles into different types. So that is electric two-wheeler, electric three-wheeler, electric passenger car, M1, N1 category, heavy vehicle, load, and so on. So these are the various varieties of electric vehicle. Any vehicle, if it runs on Indian road, needs to be certified. Otherwise, it is not required to be certified. So AI does certification in terms of emission, noise, crash test, safety. Similarly, electric vehicles are also tested as per AIS standard. So I'm going to share some of the AIS standards here. We started working on electric vehicle from last 21 years. So somewhere in 1999, a committee was formed of ARAI, VRD, ECMA, and SIAM, TMA, to find out how can we form a group. So once the group was formed, this group started discussing about various type approval of battery operated vehicle, and also their draft needs to be approved. Finally, all this thing was done, and it came out mandatory requirement from April 2005, white SO 1365E. Okay. So a lot of AI standards were formulated, and today we are using AI standards to test and certify electric vehicles. So these regulations were not only for electric, also for hybrid vehicle, also for charging stations, and so on. So here you can see the full conclusion that electric vehicle, then the standards are 039, 040, 041, or a traction battery, or the chargers, or hybrid vehicles, retrofitment of kit. That means if you have a vehicle fitted with engine, just remove the engine and insert this system, and then you will get a retrofitment. There are other standards also. So basically the Indian standards for battery operated vehicle and equivalent, there are various types of tests, and everyone is passed through that test. Okay. There are certain vehicles for which certification is not required. For example, electric vehicle below 250 watts, they just have to apply to ARI saying that our vehicle is below 250, and ARI will check whether their power is below 250 or not, and based on that, give him certification. We also put a lot of challenges among the students, asking them that how this is done and how that is done, and how do we get the exemption certificate. Why are you using white reflector on the front side? Why are you using red reflector on the rear side? And so on. As I told you, this three-wheeler has been sold by more than 6 lakhs units per year. So it's a very simple three-wheeler, but the credit goes to the Indian manufacturers who have been able to sell 6 million three-wheelers. Okay, so let us quickly look into the EV regulation. AIS 38, AIS 39, and AIS 40 are more related to the vehicle, and AIS 41 is abroad. And these are some of the standards. So you would see that here we have an AI 039 being tested on the electric consumption of a hybrid car, or AI 040 revision 1 method of measuring. And the AIS 041 measurement of net power and maximum 30-minute power. So besides electric vehicle, there are hybrid vehicle separate standards. So these are the standards for the hybrid vehicle. Then there are also standards for retrofitment. So ARI is the only country who allows swapping of battery and who allows what is that? Exchange of people for hybrid and electric system. So this AI standards on formulation of electric vehicle and hybrid electric vehicles are very, very important. And they are all done through AIS 123, part 1, 2, and 3. So there are standardizations where EV charging couples are being standardized, or maybe in future when different mobiles are being charged, here also we can have different mobiles. So there are systems like fast charging, slow charging. We need to work on that. Okay. So now from safety point of view, how are electric vehicle tested? First thing, it has to be tested in an EMI EMC chamber, a semi-anechoic room. Then a water wedding test is done. Water wedding can be done in a very confined small pond, or it can be done on Indian roads. Or whenever the crash test takes place, the frontal impact is checked. So these are some of the standards from safety point of view. So there are many sensors and actuators being used in the car, and one has to take care of all those safety requirements in the car. So for electric vehicle battery, the AI standard is 1058. So the safety of the battery depends on chemical safety, electric safety, mechanical safety, and functional safety. So this is the whole vehicle EMC test facility for 2, 3, and 4-wheeler. Okay, so this is a semi-anechoic room at AREI in Pune near Chakan, where we can put the entire vehicle, whether it is a car or a truck or a bus, and do the EMI electromagnetic interference and test. Yeah. So AREI has all the facilities for testing and certification and research and development of electric vehicles through its Center of Excellence on E-Mobility. So it is also called Green Mobility. And so there are many softwares available from Altair, from NSYS. So I can see some hands raised. I will take all the questions at the end. We are about to last 10 slides. So there are softwares from NSYS, Altair, Ricardo, Gamma Technology, and these are the companies who work very hard to simulate electric vehicles. And these softwares are predominantly used for electric vehicle. And then we have all the test facilities to test motor, controller, then batteries, and storage system. So one has to do the study of electric motor and safeties, one has to do C analysis, and one has to work on only lithium-ion batteries, and so on. Also, we need to check from electric shock point of view. We need to check from crash evaluation criteria point of view. Okay. So whenever any crash test has to be done on an electric car, one must wear the entire flame resistance clothing and come out with insulated tool, because in a crash test, there is a possibility that the vehicle may catch fire. especially when you have all these electronic components being used. So for the EV risk mitigation strategy, isolation from high voltage components, absence of high voltage, crash event, enclosure integrity. These are all areas where we must, parameters where we must work on the mitigation strategy. So ARI has also developed a website called emobility.ariindia.com. Okay, so what ARI has done is ARI has developed certain charging systems, and ARI has launched the website where anything related to electric vehicle is mentioned. So you can find the AI standards, you can find BI standards. It will be like a small book, a small library, and a lot of activities. So finally, I go to the last point of my presentation, maybe another 5-6 slides, where we talk about skill development. What is important is that the teacher has to part this skill to the students, and the student must be able to assimilate. For example, when we talk about skill development, we need to entirely form a new skill, or we can get a speaker and support it by our AI speaker, and then do a reskilling for automotive sector. The best would be the new skills from other sectors other than auto, and the skill replace removed from auto sector. So these are the 4 areas by which we can improve the skills of human being. So for example, student skills can be honed by eBaha. eBaha is an initiative of SA India and ARI, where we ask students to make their car themselves and make their hands dirty by designing suspension, steering, brakes. And then based on that, the judging is done. So in 2014, we went and met Dr. APJ Abdul Kalam, and we requested him to come as the chief guest. He said, no, I will not come as a chief guest until you get some indigenized competition. This is a world famous competition where you take an imported engine and load it. I want an Indian engine and the Indian fuel and all those things. So we came back, we worked, and then we finally decided to launch electric vehicle in 2015. And unfortunately, Dr. Kalam expired before he kept his promise, and he was not able to visit ARI. So ARI has been selected by DHI, Department of Heavy Industry, Government of India, where it says that we have to conduct an EV awareness program in various colleges. So we have visited around 10 colleges and we have created awareness program. But in case somebody is interested that we can come to your college and do the awareness, please write back to me. So besides postgraduate diploma program, we have also started working on the electric programs. So under 1 year postgraduate diploma in electric mobility. Okay. So we have a postgraduate diploma course for 1 year. We have an MTech course for 2 years. One is called electric mobility, another is called electric and hybrid vehicle. On an average, 3 lakh students go abroad for doing their master's course in Europe and USA, Australia and other countries. But because of COVID-19, the international flights have not started. The visa offices have not started. So they have not received any visa, and neither they have been able to book the flight tickets. Most of the students said that they would go abroad next year. They have written to those universities that we may not be able to come, but can you take us next year? By that time, things will be normal. So the government has agreed. Most of the foreign universities have agreed to allow them to take next year. Now, what will they do for 1 year? So many inquiries are there that we will do 1 year postgraduate diploma or we will do a 2 year MTech program. So by doing so, the branding and the courses are becoming more and more popular. So just last week, we started a new course on postgraduate diploma in electric and autonomous vehicle. And in case somebody is interested, they can join for this 1 year course. Okay. So in this 1-year course, there will be 3 trimesters. Student will be studying in first trimester at the parent college, second trimester at ARI, and third trimester will be a project and practicals. So ARI conducts a lot of programs on electric vehicle awareness. So we have conducted around 25, 27 programs. And most of these programs are very successful. So in short, what I want to say is that we need to develop components, subcomponents, and the vehicle. We must get raw material handy, and we must be able to assemble these parts and end of use and end of life, EV charging infrastructure and EV use and end of life. So this is what I would like to say in conclusion. So in short, let's work together for penetration of EVs in India, and let us transform the skill landscape. So as the faculty advisors or as faculty of various engineering colleges, it is my request to improve the penetration of electric vehicle. It is my request to talk to the students and motivate them to buy electric vehicle when they grow up. And till then, thank you. You can note down my email ID. It is mentioned on the screen, vora.pga@ariindia.com. Feel free to write to me in case you need any help. And wish you all the best for the program which has just started today.
Sir, thank you very much, sir.
Thank you. Yeah, so if there are any questions, please feel free to ask.
Yes, sir. Yes. So thank you, sir. Thank you very much. Now we have 2 hand raises here, sir. Now, Dr. Venkatesh, I'm unmuting you. You please ask your question to Vora, sir.
Yes.
Yes, sir. Sir, good evening,
Yes.
sir. Good evening.
Thank you.
Yeah.
Yeah, sir. It was nice session. You have shared your versatile experience with us. It was fruitful, in fact, for academicians, especially because a lot of things we have came across in your slides, which is actually practical scenarios. Thank you for that, sharing your experience.
Yes.
Sir, my question will be like retrofitting. You have also used that word many times, no?
Yes.
So is it possible to exchange the existing vehicles, the engine vehicles, to retrofit to electrical vehicle? Because again, to manufacturing a new vehicle with electrical vehicle, it is a costly affair in terms of materials as well as plastic also. Plastic is another hurdle for us.
Yes.
So that 2 things we can avoid. And sir, one more question. I'll ask only 3 questions I have. Okay.
Sure.
And how safe this battery is, because anyway, whatever the stored energy in battery is in direct DC, no? So in case accidents, no? So DC will be much more harmful than the AC. That is what, for curiosity, I have asked that question.
Correct.
And the last question will be, since you have mentioned, we have restricted now importing all the things from the China or so, especially magnet and all. So what is the other potential areas in India to manufacture an indigenous electrical vehicle? Over to you, sir. Thank you.
Yeah. Fine. So there are 3 questions. I'll reply to them one by one. First is retrofit. Yes, it is possible to convert a normal IC engine vehicle into electric vehicle by removing the engine and putting the kit. Right. I request everyone to switch off mute their mic.
Yes, sir. Yes, sir. Continue.
Yeah. So it is possible to retrofit. India is the only country which has formulated the retrofit e-kit standard. No other country is working on retrofit, but considering 250 million vehicles running on Indian road, it is a very strong desire to work on retrofit. Already 3-4 companies have taken approval for retrofitment, and I am sure in India it would work. But one has to be careful, because whenever you change part, there could be higher results. I remember that before some 20 years, when we were working on CNG, we converted a lot of vehicles in Delhi into CNG, and they were using some spurious parts, because of which some fire also took place. So here also, the standard for retrofit is there. And every retrofit kit manufacturer have to take approval of ARI by detailed testing, and only then the retrofit must be allowed. Similarly, India is the only country who is now working on swappable battery. That means You give your new old battery which is discharged and take a new battery which is charged and move on. You don't have to wait for charging. So retrofit and swappable battery is all possible in India, but we need support of the public, and I'm sure that we will get this. And then we will be able to see, we don't have to buy new vehicle, we can convert the existing vehicle. Second question was on battery safety. Yes, battery is the most vulnerable part in a car, in a vehicle, and that has to be 100% safe. So we do series of tests on the battery. For example, there is one test called nail penetration test. That is, we hammer a nail inside on the outside surface of the battery and see what happens. So there are series of tests. There is an endurance trial of battery, dynamic events for battery. So all these testing are done to ensure that we have a foolproof battery system. Also, battery management system will keep on monitoring the temperature and the stress, and will keep on informing this is what is happening. So somebody can take a corrective action. The third was China. Yes, government has taken a decision, or we all have taken a decision, that we will use less Chinese product, and hence there are many who does not want to get their components from China. India has started working under lockdown. China has started working, and the factories have started working. And now, if these parts don't come, and those who are dependent on Chinese material are at loss. But it is not so that only China can supply such material. There are many Indians who are startups and who have started working on supply of material. And if they can make a cost-effective solution, then the vehicle manufacturer will be ready to buy from them too. So these are the three answers. I am very sure, for example, in Pune itself, people have started. For example, the motor requires a magnet. So in Pune, the magnet manufacturing has started. Like that, automatically, when things don't come to our door, we will try to find out options. And that's good for the economy. Thank you.
Yes, sir. Sir, second person, Anil Kumar.
Yes.
So he has a doubt. Yeah, Anil
Hello.
Kumar. Sir,
Hello,
you
sir.
can ask the question. Yeah.
Good afternoon, sir.
Good afternoon.
Sir, very thanks for your nice presentation, sir.
Thank you.
Sir, earlier I came to know, I attended one earlier FDPs. They have told one of the problem being faced for e-vehicles is cooling of the battery management system.
Yes. Cooling of the
In that-
battery itself. Yeah. What is your
Yeah.
question?
In what way the battery management, that battery system, what are the special requirements to make it cool as
Right,
per that
right.
changes to be incorporated by the mechanical design changes?
Sure. So battery is one of the most important component which has to be given special attention. So like the state of charge, state of health of the battery needs to be checked. The temperatures of the battery need to be checked, and whether individual cells are proper, and the group of cell together as a module and a group of module together as battery pack is very important. So what we do is we have a battery management system which takes care of everything related to the state of charge, state of air, the temperature at various locations. Everything is mapped properly, and then corrective actions are taken. For example, there are 3 levels of temperature. When it crosses, it gives a signal. So the first time it crosses the signal, then the conventional cooling will take place, or forced draft cooling, or water cooling. So nowadays we have battery which are surrounded by water jackets, and you can cool the battery with the liquid cooling medium. Also, the temperatures are measured, and when the temperature goes about 60 degrees, 70 degrees, then there could be a cutoff also. So how battery needs to be cooled? Static cooling of the battery, then dynamic cooling of the battery through various mechanisms. So a lot of research has been done in the battery to make it more cooler. Same thing with the motors also, and the entire e-kit. And one has to be very, very careful. If the temperature shoots, then there will be a cutoff, and the vehicle will not be able to move forward. I hope that answers your question. So there is a company called Device Electronic in Pune who gives a lot of training in battery management system. If somebody is interested, they can undertake training there. ARI is also planning an internship program of 1 month where we will be giving various lectures and conducting practicals on electric and hybrid vehicle for the students. We are planning to launch that in August 2020. I hope that answers your question.
Yes, sir. Yes, sir.
Thank you.
We have another person. Venugopal, sir.
Sir, good afternoon, sir.
Yeah.
Vora, sir, you got an extensive.
I can't hear. I think
Sir, your voice is not audible. Venugopal, sir, your voice is not audible. Can you?
Okay. Sir, now is that okay, sir?
No,
Sir, am I
not
audible to
clear.
you now?
No, not clear, sir. You keep your mic nearer to your voice.
Sir, now it's okay, sir?
Okay, you can ask the question. Somebody will tell me what is the question.
Okay.
Yeah.
Sir, the subject content was extensive and a huge lot of data is available. Can we have the copy of it?
Adinarayan sir, what is the question?
Yes, sir. This is
No,
about
sir.
sharing your presentation with that participant, sir. PPT is. I mean.
Okay,
the
I will
content
share
is
this
very
presentation.
informative.
I will share this presentation to Dr. Adinarayan and then he can share with you.
Yes, sir, definitely.
Thank you.
Okay.
Right. Yeah. Sir, we'll see another person.
Yeah.
Veerbhadrappa.
Yeah, Dr. Veerabhadra.
From?
Dr. Veerabhadrappa.
Please mention the name of the college also.
Yeah.
In the city. Yes, Dr. Veerabhadra, you're from which college, which city?
Yeah. Trying to unmute, sir.
Go to the next person, Naidu. Virendra.
Yes,
Virendra is there.
Yeah.
Hello, sir. This is Virendra from
Yeah.
Priyadarshini College of Engineering, Nagpur.
Okay.
Sir, what are the safety precautions in terms of fire?
Yeah, so this is a very good question. So I can show you one slide. Let's see if I can show you this here. Yes, 1 minute. So these are the equipments which are used. So you will see that fire and crash, these are the two important criteria for an electric vehicle. So a special tests are done at ARI, and before any crash test, the operator has to wear this special PPE kit, and then they must use insulated tool. The fire brigade is ready, the fire extinguishers are ready, and then the crash test is done. Now, one has to ensure that fire does not take place. So the battery management system has to be properly checked, and the consistency of battery management system also needs to be checked. The reliability of the system needs to be checked. So there are on-off mechanism, increased temperature, decreased temperature done on the battery to ensure that the battery management system controls the temperature. So when the temperature goes up, then the cooling starts. When the temperature further goes up, supercooling charges, and the temperature further goes up, it trips. So then the vehicle will stop, the motor will stop. So this mechanism is very, very important. In spite of that, fire cases do take place. And this is because we use spurious part, or if the thermocouple has come out, or the closed loop system of the sensors and actuators are not working. So we need to do a design FMEA to find out why the fire will take place. There are institutes in Sweden who does extensive work on fire protection. So most of the vehicle manufacturers get their vehicle checked by this Sweden institute in terms of fire protection. But still, fire do take place. We have to be careful. But fire can take place in a petrol engine also, and fire can take place on an electric vehicle also. We have to be careful.
Thank you, sir.
There are many softwares which are imbibed to find out what are the temperatures, to predict the temperatures, and to guess some temperature, so that precautions can be taken. Okay.
Okay. Now, Mr. Rajesh Saluja, you can ask your question.
Yeah, good afternoon, sir. Sir,
Good
am I
afternoon, Rajesh.
audible?
You are from which college?
Sir, good afternoon. I'm Dr. Rajesh Kumar Saluja from MET School of Engineering and Technology, Delhi.
Delhi. Yeah.
Yeah, sir, thank you for such a wonderful, informative lecture, first of all. Sir, it is very glad to see that there has been a lot of development in e-vehicles. Sir,
Yes.
however, still we find there are certain challenges.
Yes.
Sir, I would like to request you to enlist a few such challenges which can be the prospective areas of research for BTech or
Very good.
MTech
Very
student
good.
level.
Yeah. So I will show you a presentation where we have enlisted. Today morning, I had a presentation to the research field. So just give me 1 minute. I'll open that presentation and I will enlist all those what we can work on. Just give me a minute. PPT. EV. Okay, I have around 10 slides which will talk about what type of research academia and industry should do. For example, what type of research can we do in India? Can we make concepts? For example, you can make various concepts of electric vehicle, hybrid vehicle, and how where those components will be fitted, where will be the motor, where will be the battery, whether the motor will be in the wheel hub or in the floor of the car. So can we do modeling? So there are software from Ricardo, Gamma Technology, Altair, and NSYS who has done extensive work on electric vehicle and their softwares are related to electric vehicle. So can we model the vehicle? Can we do a simulation? Can we do optimization using all this software? Can we make a prototype of a vehicle? Can we make EV retrofit kit and try it? Can we take an existing IC engine vehicle and convert it to an electric vehicle? Can we do work on battery swapping? Can we make a BMS? So for example, in e-Baha competition, we ask students to make their own battery management system. And how can we do system integration of all this? So these are some of the questions which you can ask. Generally, when we do a research, we do product development in a V model. When I say V model, you need to understand what do the customer wants. So the requirement specifications are found with the help of quality function deployment. It's a process by which you capture the voice of the customer, then convert them into system functional architecture design and sub designs and detailed design and then optimization. So when you do subsystem design, it is more of component. And whenever you do system functional and architecture design, it's more related to DVP and design validation plan verification. And when the entire vehicle is ready, then you do the system validation and check that whatever initial requirement and specification were decided are met or not. So this is one important aspects of research. So here I have listed around 8 current research topics. For example, electric vehicle architecture. So whether we are going to use electric vehicle, hybrid vehicle, or plug-in hybrid vehicle or fuel cell vehicle, or electric motor, whether you have electric motor of high efficiency and high torque motor, or energy management system efficient algorithm for BMS, big data, artificial intelligence, vehicle to cloud prognostics. So there is a lot of data available and we must be able to feed this data and able to find out what is the meaning behind this data or what is the message behind this data. Then we need to talk on energy storage system like lithium batteries, ultra capacitors, and what will be the role in battery storage system or energy storage system. And then we can also work on software architectures and smart charging solutions and in-vehicle networking. So these are some of the research area where Indian academicians can work, and so they can work extensively on different types of electric motor and do a comparison, or they can work on energy management systems or battery management system. So they can work on metal layer batteries, glass battery, lithium ion batteries. They can work on supercapacitor and hybrid energy storage system, HESS. Then how the charging would be done is what is discussed. Then the battery swapping mechanism, remove the old battery and put the new battery, or intelligent solution for charging. Does that, so these are some of the research area. I am not going to take more time on this, but big data analytics is another area. So professors must work on data analytics. There are a lot of courses, and then a lot of data is coming out. How are we going to debug this data and analyze the data? And the next step is from electric vehicle, we shift to autonomous vehicles. So we need to work on artificial intelligence and machine learning, and then work on networking, and then finally make an autonomous vehicle, right? So these are the some of the research area which I will talk about. For example, how do you increase the range? How do you integrate the vehicle? How do you take care of safety and durability and performance engineering? Are some of the subjects on which you can do research. Thank you very much.
Thank you, sir.
Mr. Rabiram, you can proceed with your question.
Sir, Mr. Abhinaya is there, sir. We have unmuted her. Yeah, please, Abhinaya.
Yeah, please.
Yeah, please introduce yourself and ask your question. You there?
Hello.
Yeah. Please introduce and ask the question.
Yeah, sir. Myself, Abhiram. I'm assistant professor from Mechanical Engineering Department, RV College of Engineering, Bangalore.
Bangalore. Yes.
Yeah.
College. Yeah.
Yeah, sir. It was a nice presentation, sir. I have one or two questions. That's all.
Sure.
Yeah. The first question is in India, where do we stand exactly with respect to PHEV, sir, plug-in hybrid electric vehicle?
See, in India today, we are all cost-conscious people, right? So we want everything cheap. Electric vehicles are costlier than the regular vehicle because of the cost of the batteries and the lithium ion used in the batteries. And hence, when you compare the cost of a normal vehicle with an electric vehicle and then with a hybrid, plug-in hybrid vehicle, plug-in hybrid are always costly because there is an engine also and there is a battery and motor also. So from that point of view, hybrid vehicles are not viable solution in India as on today.
Okay.
But eventually I can see that there would be a transition from electric vehicle to hybrid vehicle. And we need to have this transition from today's vehicle to the future vehicle. So I think after a couple of years, hybrid vehicles would become more popular. Right now it's costing, which is creating a big impact. If you go to Sri Lanka, you will find more than 50% of the vehicles are hybrid because they import second-hand hybrid vehicle, but government gives a special subsidy in terms of exemption from income tax, and that's how the system is working.
Okay, sir. Thank you. The second question is, sir, in one of the slides that you shared, approach to mobility transformation, there was one particular slide, energy consumption from motorized passenger transport would decrease by 64%. I didn't actually catch that point, sir.
Okay, let's try to open the presentation and check. Give me a couple of minutes to open the presentation. So I'll close this presentation and open this. Can you repeat your question? Till then I'll just go
Niti
through it.
Aayog report, approach to mobility transformation.
Fine.
In
Niti
that,
Aayog. Let me open Niti Aayog report.
yeah, slide number 50, sir. Yes.
Yeah.
So in this, if you see energy consumption from motorized passenger transport, it would reduce by 64%, something you have shown. I didn't get that point actually.
Yeah. You're talking about that 60%.
Yeah, yeah. What exactly is that, sir?
Yeah. So what is Niti Aayog saying, that if instead of petrol and diesel, if we use electric vehicle, we will save 64% of the anticipated road-based mobility related energy demand. Our energy demand will go down because we are running the vehicle with the help of electricity and not with the help of fuel. So when we use fuel, we have to pay for the fuel, which is very costly, like 80 rupees per liter. And we are burning that energy, that fuel into energy, and then we get only 20-30% energy out of it. Rest is all waste.
Yes, sir.
So under that circumstances, whether we must shift to electric vehicle or shared or connected mobility is what we need to discuss. But it will be a huge saving to us, and because of it, the income tax slabs may also reduce. You got the point, right?
Yes, yes, sir. Sir, one more small doubt that suddenly popped up. If we are trying to move towards electric vehicles, and we want to popularize electric vehicles and make sure that we buy electric vehicles, then it will be a huge burden on electricity production also, right, sir?
Yes.
Like,
Yes. So very good question you asked. It is very relevant question. So first thing is, why are we using electric vehicle, and why not? What is wrong with conventional vehicle? If it is costly, fuel is costly, only those who can afford can buy it. What is important is that all these people are moving towards city. The villagers are also moving towards city. And by 2050, it is said that more than 50% of the Indian population will be staying in the cities. And these cities are all well-defined 50 cities, for example. So if you want to reduce pollution in these cities, we need to generate electricity somewhere outside, and then transfer this electricity in the city and use this electricity to light to use the charging.
correct.
Now, if we start using electric vehicle in the city, the overall pollution level will go down. That is what is the main aim. Now, your question, what was the question? Can you just repeat the question?
The question was the demand for electricity will grow, and obviously we need to burn more fuel to generate the electricity, right?
So when more and more people start buying electric vehicle, then we require more and more electric energy, and you may say that we don't have enough electricity in our villages, and the electricity goes off frequently and so on. Then how can we afford to have this? So you may not be knowing, but parallelly, like we have Ministry of Heavy Indian Public Enterprise for automobiles, which governs ARI. We have Ministry of Petroleum, which creates BS6 fuel, less than 10 ppm sulfur diesel and all those things. Similarly, we have Ministry of Transport, who looks after the infrastructure, safety, and roads and highways. Similarly, we have Ministry of Petroleum, who looks after the fuel. And then we have Ministry of Power, who looks after the generation of electricity. So the aim is to shift towards renewables. That means use solar power, nuclear energy, wind power, hydel power, and not thermal power plant. So this is what is the Niti Aayog thinking to shift. And if we are able to succeed, then it will be a real mobility transformation.
Thank you so much, sir. Thank you so much.
Sir, next we have a question from Salman Khan.
Oh, Salman Khan.
Yeah, sir. Sir, please unmute yourself and ask the question.
Sir. Yes, sir. Yes, sir.
Salman Khan, you are from which college?
Sir, very good afternoon, sir.
Yeah, good afternoon.
Sir, I'm working as a professor in KG Reddy College of Engineering, Hyderabad.
Okay.
So my question is that, sir, as we have told that to reduce the temperature, we use various types of coolants for the battery.
Yes.
So, for example, if you take as the latest vehicles, two-wheelers, so we are to reduce the amount of cooling system, we are using air cooling system.
Right.
So, in batteries, if we use liquid cooling system, it does not increase the dead load on the vehicle.
It increases, but when you have to really reduce the temperature of the battery motor and make it more cooler, so from safety point of view, it is safer. We need to use liquid cooling. So more and more people have started using liquid cooling. For example, if you take a battery, then it is surrounded by water jackets, and you can put water in it or any coolant in it, which will continuously cool the battery. So the trend is changing, and you can use any type of cooling system.
So what are the different types of liquids which are used for cooling, sir? Can you suggest any of the liquids?
Same what we use in radiator, ethylene glycol, water.
Like normal oil cooling methods which are using for IC engines.
Yes, all those can be used.
Okay. Thank you, sir. Thank you very much.
But the cooling is more towards forced draft cooling or liquid cooling, but both are used.
Okay, sir. Thank you very much, sir.
Yeah.
We have another question from Manoj Pawar, sir.
Okay.
Yes, sir. Please, Manoj Pawar, sir.
Yeah, sir. Good afternoon. Myself, Dr. Manoj Pawar, speaking from KJ Somaiya College of Engineering, Mumbai.
Manoj, we met last
sir,
week.
Yeah. Sir, very informative session with lots of data and statistics related to electric vehicle. So my question is now, as the very big force is there to shift from a conventional vehicle to electric vehicle, the most of the colleges are in the interested to start either courses or programs in electric vehicle. So being the faculty part, how we can be equipped ourselves so that we can be deliver the courses in good manner, so that the knowledge can be transferred from ourselves to students. What will be your suggestions?
Yeah. So ARI is here to support the academia in terms of knowledge upgradation or reskilling of professors. So we can do a faculty development program. Like I said, in 3 months, we have conducted 25 training program in electric vehicle awareness. So you can join these training programs. We can help you to design syllabus. We are also planning an internship program where students or professor can come and stay with us for a month and learn how to test and certify electric vehicle, or how to do research and development of electric vehicle. We have a center of excellence in simulation, a simulation lab where you can come and do various simulations. There are people to help you out. So we can do a lot of areas where we can train the teacher. We can come and give lecture in your engineering college and train the teachers, train the trainer. Also, a lot of work is required to be done. It's a huge work. Slowly, steadily, we are convincing engineering colleges to. We are also making e-learning modules where students and professor can go through those modules and learn. So there are many areas by which ARI can help. Once in a year, somewhere in second week of October, say October 2020, we will be calling all the professors and students from various parts of the country. Every year, around 1,000 students and professors join us. We can show them this center of excellence in e-mobility to them. So these are some of the areas where we can help you.
Sir, this question is continuation to that.
We have a very good library, and all the books related to electric vehicle, you can take advantage of that library also. Yeah. You said something, Manoj?
Yes, sir. Yeah, in continuation to this, what is the procedure for faculty to get internship or to do internship at ARI, sir?
We have not worked. We are planning to start this internship program in first week of August. I think the fees would be something like 20,000 rupees per month. It is a very nominal fees which includes breakfast and lunch also.
Okay.
Okay, sir.
Okay, sir. Sir, another person, Dr.
Write to me separately, we can work on it.
Yeah, yes, sir. Sir, Dr. Venkatesh.
Yes.
Sir, Dr. Venkatesh, please,
Yes, sir.
please, sir.
Sir, good evening, sir. Good evening. This is Dr. Venkatesh from BMS College, Bangalore.
Okay.
Sir, my question will be like, since the existing conventional engines, no, sir. So we have many technology, GDI, CRDI, all this technology, which is pertinent to specifically thermal field.
Yeah.
And the major role of thermal engineer used to play to ratify all the problems. But what is the actually key core parameters in electrical vehicle pertain to the thermal engineer, sir, actually? Because when you say IC engines, it is engine is a core part, and a thermal engineer will be playing a major role. Now, in that concern, we are replacing the engines. So, what will be the core importance of the thermal engineer?
Yeah. So for thermal engineer, it is more of a thermal management system where you need to control the temperature so that nothing overheats. And that's a very big area where you can do CFD simulation and internally, externally to find out what type of cooling are required and how to make cooling more effective. So this is what engineers can do. I think we need to get reskilled. Irrespective of whether you studied in your college or not, you can always reskill and start working maybe 10%, 20%, 40% of your time in studying electric vehicle. That will help you.
Sir, one more question, sir. We have started thermal engineering branch for PG course in our college. So what are the chances for students to get internship or the project in ERA? What are the procedure or any chances for students?
Chances are very less because we have our own collaboration. We have around 250 students studying with us all the time. So first preference is given to them for the projects. So very rarely we will take people from outside. Yes, nothing is impossible. If the student is really interested, he can make it happen.
Yeah. Yes. Sir, another participant, Piyush. Yeah, Piyush, please. Piyush, please unmute yourself and ask the question.
I have
yes, sir.
another
Yes, sir.
meeting at
Yes, sir.
4:30.
This is Piyush.
4:30. So maybe I can take a couple of questions.
Sir, few minutes.
Yeah.
Sir, actually, there is a question that with the increase of this electric vehicle, we are more dependent upon this lithium-ion battery, and recycling of this lithium-ion battery is a challenge. So how we are going to meet this challenge? Because see, if you go for if you purchase a laptop and after a few years the battery gets dismantled, completely destroyed. So when you go to the manufacturer, they don't take it back. They because they don't have the facility to recycle it. So the same will be there with electric vehicle batteries. So how to meet this challenge? Because after a few years there will be a lot of
So we have already formed a committee who is working on recycling, reusing, and reducing of batteries and other component electric vehicle. So the 3R would be implemented in this. And for example, a very strong recycling community is coming up in India because government is seriously thinking to scrap automobiles. Automobile which has completed 15 years, 20 years is scrapped. Right now, we already have a scrappage policy for commercial vehicle, but there is no scrappage policy for domestic vehicle because people may be unhappy if this happens. In India, the life of a vehicle is higher than the life of a human being. The son also uses, the father also, the grandfather also must have used a vehicle, and it passes on from one generation to another. The vehicle continues to live. But those days are gone. Scrappage policy is coming soon, and it will become very, very costly affair to continue the registration of this vehicle after 15 years. It will be costly for re-registration. So there are a lot of other things being done to ensure that the vehicle gets scrapped. And when the vehicle gets scrapped, the automotive industry will also get more business and the economy will boom. So there are certain components in a scrappage system which can be retrieved. For example, rhodium and platinum and in the catalytic converter needs to be retrieved. Lithium from the lithium ion batteries need to be retrieved. So there are many mechanisms by which this is going to happen. And as on today, even if you throw away your lead acid battery, you don't do that, because there is always, they will say, okay, if you return me the lead acid battery and take a new one from me, I'll give you a 1,000 rupees discount. So then why do you lose that 1,000? You give the battery to him and he gives you a new battery. He sends it the battery for recycling. So today no one is throwing away lead acid battery on the road. Similarly, no one will throw away lithium ion batteries on the road. Yes, it can be reused, and that's what we are all working on. I hope that answers your question.
That's sir. Final question.
Yeah, last and final question by Dr. Sudhakar.
Thank you.
Yes, Sudhakar sir, please.
Yes.
Sudhakar sir, please unmute yourself and ask your question.
You can close, sir. Probably.
We can close.
Sir, what is the life of electric vehicle, sir? Actually, we say that normal engines we have 15 years, sir. So registration for electric vehicles also given for 15 years, sir.
Yeah, 15 years, 15 years. So whether it is an IC engine vehicle or an electric vehicle, the registration would be for 15 years. Yes, the battery life may be 5 years, but we can always change the battery. So batteries are now given on rent. So when the vehicle is sold, the batteries are not sold, batteries are given on lease. So for example, if the cost of a two-wheeler, electric two-wheeler is 1.5 lakhs rupees, you pay only 1 lakh rupees for the vehicle, and battery you take it on lease or rent, and you pay only 1,000 rupees per month. It is like instead of petrol, you use that. So this is how the system are going to work. And then you don't have to worry about the battery charging or battery getting useless after 5 years. It's the job of the person who gives you the battery on rent. So the same company will give you battery on rent and also sell the vehicle. So instead of 1.5 lakhs, you pay only 1 lakh rupees. That's how it will become lucrative.
Thank you, sir. Thank you.
There are small questions, sir. At AIRIA, you are actually offering several certificate programs. Now, is there any placement support also there for the students, sir?
No, there is no placement support. Right now, the industry is not doing well. So if we do a big internship program, we help them in placement, but there is no commitment.
Okay, sir.
And it's very difficult to get placement these days.
Yes, understand, sir.
But we can support in future, not now.
Yes, yes.
Sir, one more question is there from participants. Shall we take, sir?
Yeah, sure.
Last and final.
Yeah, Krishna Verma, please introduce yourself and ask the question.
Yes, sir. Thank you very much for giving this opportunity, sir. Vara, sir, very nice presentation, sir. My question is, in one of your slides, you have mentioned this Norway is having 50% of sales in electrical vehicles, and very poor is our India. It is having around 0.5% or so. What is the reason, sir? Actually, why Norway is in that stage and India is in very less stage?
So Norway started long back, and the government of Norway has given lot of incentives to them, and that country was highly polluted country, and they felt the effect. And then they took a decision that we will reduce the pollution of the country, and then one of the solution is use of electric vehicle. Other solutions are like carpooling, using cycle. So they use bicycles, they avoid using car, and even if because it's a very small country, it's a small area and a small population. But the population was getting affected. There were a lot of health hazards. So that's how the decision took place. India has also understood the importance of electric car, and that is why Niti Aayog has said that by 2030, that is in the next 10 years, there must be 30% electric vehicle being sold. So the penetration should be 30%, whereas today it is just 0.1%. We need to move from 0.1% to 5%, 10%, 20%, and 30%. It's a long way to go. But I am very sure the awareness program which are being conducted are convincing people, and more people from society perspective point of view have agreed to buy electric vehicle. But there are constraints. There is an anxiety in terms of the range of the vehicle, how many kilometers it will run without charging. There is an anxiety on the cost. There is an anxiety on the life. So all these anxieties will towards electric vehicle will increase, and then the penetration will increase. So we must target at least by 2040, if not 40% or 30%, at least 10%. So we need to start moving towards that.
What are the possible alternatives of research, sir? We can look into for increasing to go to that stage.
Oh, the topics of research you are saying?
Yes, sir. What are the possible alternatives, quick alternatives we can look into?
Say retrofitting, swapping, cooling of the entire kit. These are some of the alternatives, some of the areas where you can work. And you must work more on software related areas, like use of MATLAB, use of all these softwares, or prediction of thermal management, and for prediction of life. So all those things must start immediately. There are software companies who are supporting this. I can talk to, if you're interested, I can talk to some of the software companies. They can give you initially some free version of software, and then you can convince your colleagues to buy all this software. But some of the softwares have become very good.
Can you suggest us some software companies, sir, which you will give free versions?
You can write to me.
Yes, sir.
With your plan, what you plan to do, and how many students you have.
Yes, sir.
My job is to forward it to some of them and find out how can we help you in that. Fine.
Okay, sir.
Or if you want to use software, they are available at AREI. If you happen to come to Pune after the pandemic ends, you can use those softwares on our desktop for a couple of days.
Thank you very much, sir. Thank you very much for your offer, sir. I will definitely look into that, sir.
Sure. You can send me an email.
Yes, sir. I will email to you, sir. Thank you very much, sir, for giving me this opportunity.
Thank you. Okay, I think it is 4:25.
Yes,
and
let's. Yes, sir. Yes, sir. We'll close.
If there are any questions, my last slide has my email ID. I'll just show the email ID. Here. Sorry. Where did it go? I'll just show you my last slide and then we can stop.
Yes, sir.
My email ID is vora.pga@areiindia.com. So please feel free to send me an email if somebody has some more questions.
Thank you. Thank you very much, sir, for being with us and enlightening us in the direction of electric vehicles. It's really a very informative presentation, sir. Thank you very much.
Welcome, sir. Welcome.
Thank you, sir. Thank you very much.
Welcome. So I'll take your leave today. Thanks a lot.
Yeah, yes, sir.
Thank you.
Yeah.
Naidu sir, if you have any announcements to be made, you can make those announcements.
Participants, tomorrow's session as usual starts at 10 o'clock. 10 o'clock. And from 10 to 11:15 first session, 11:30 to 12:45 second session. So kindly join in the above same link which we have forwarded to your WhatsApp as well as email for tomorrow's sessions. Thank you.
I think Naidu, someone is having a question to ask, I suppose. Maybe
No,
not
sir, no
related
hand.
to the presentation. Yeah.
No
One
hand. No,
Kavita
it's
Devi.
not hand raised. I think it is. Yeah, I'm looking at it.
No, if it is related to something related to the schedule of the event, then we may answer, right?
Sir, it is, I couldn't able to see it.
Okay, no problem.
Yeah, Kavita Devi. Yes, ma'am, Kavita Devi, if you have any questions, you can ask. Yes, ma'am, you can. Ma'am, do you have any inquiry?
Okay. Naidu, shall we stay back just for a few minutes for debriefing?
Yeah, yes. Sir. I'll be here.